Okay, so we have another ambiguous case triangle, two sides and an angle, right? Now let's start with angle A like we have in the past. I'm just going to draw a horizontal line. Okay, I don't know how long, this is our third side. I don't know how long this side's supposed to be. But angle A is 80 degrees. Now think about an 80-degree angle, okay? Very steep, right? Not quite 90, right? Not quite 90, but pretty darn steep. So if I'm going to call this angle A, all right, and the side A is 19, I'm going to say this is side B, or angle B is going to be over here. So wherever this one stops, okay, I'm going to have to connect down here. So B is supposed to be, side B is supposed to be 25. Side A is supposed to be 19, okay? So if you think about this for a second, if I make this, relatively speaking, let's say that's 19, okay, right there. What do you notice? First thing, my first glance is like, I don't think this side is actually going to ever touch this side because it's not as long as this. Okay, now this is just one scenario where I've drawn this out. Okay, and you can't trust a freehand drawing that you're like, yeah, that looks, maybe that's 19 if that's 25. You can't really do that. Okay, so for the sake of argument, let's say that this did complete a triangle, and it'll make it easier on us when we're actually looking at this. So here's our side, angle B, right? So the only reason I show you that is to say, going into the problem, we can surmise, I don't know, this seems kind of fishy right off the bat, right? So here's our 80-degree angle, 19 across from that, side A across from angle A, and then side B across from angle B, okay? So the first thing we're going to notice, once again, is that I have a side and an opposite angle. So I can set up a ratio in the law of sines with this, and I can set up half of this ratio where I have the side but not the angle. And then we can go through the math here, right? We'll cross multiply. We'll have 25 times the sine of 80 equals 19 times the sine of B. And I'm solving for B, so I'm going to divide both sides by 19. So I have the sine of B equals 25 sine 80 over 19. And just for kicks, what are we going to do next, right? What are we going to have to do? We're going to have to solve for B. So we know we're going to have to take the inverse sine to get B by itself. So let's take the inverse sine. We're taking the inverse sine of this, okay? So side note, I know I mentioned this before in class and in some videos, trigonometric packages like this represent a number. So really 25 sine 80 all over 19 is a product on the top divided by 19. So this represents a singular number, right? Chances are it's going to be a decimal. So I need to take the inverse sine of that to get at this value of B. So just leave that as that one package. That way we only have to go to the calculator one time here. Okay, let's clear out the previous problem. Double check to make sure that we're in degree mode. Okay, we are. So we're going to do the inverse sine of, I've already forgotten, 25 sine 80 over 19. Oops. (25 sine 80 over 19. What do you notice? Right? Can't do it. And you're like, well, maybe I didn't do the calculation right. So what's 25 times the sine of 80? Okay, that's 24 point something something something. So 24.6201938. Let's check to make sure that I'm actually using these numbers right. And I get 1.2957. Okay, so what's the inverse sine of 1.2957? It's undefined, right? And again, the reason for this, we could go into greater detail about that. One of the reasons for this is that you can't take the inverse sine of a number greater than 1. Okay, it has to do partially with the unit circle, but we could talk about this, I guess, now, because we've already determined that the answer to this question is there's no solution. Okay, or we would say no such triangle, because we tried to do this one calculation and it didn't work. So think about this for a second. If we're saying, and go back to look at this calculation, we're saying that when I do inverse sine of this, I'm saying this is the angle that has this value as its sine, okay? And when you think about a right triangle, okay, and you think about a sine ratio, take this angle, for example, the sine is this number, right? Let's call it x over this number. So the sine of theta would equal, in this arbitrary case, x over y. So what we're saying in this problem is this output is 1.29, blah, 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 whatever was on that screen, which would mean this number in a fraction. If the value of a fraction is greater than 1, that means this number is bigger than this number. But in a right triangle, you can't have this be longer than this because that's the hypotenuse. So really, we're violating the tenet that the longest side of a right triangle is a hypotenuse when we're trying to evaluate a sine that's greater than 1. That's why there's no solution. So long story short, we set everything up right. Our math is correct. We've double checked it, and we're not getting any answer. That just means that there's no such triangle, which we saw from the beginning with our very crude freehand drawing, saying, I didn't quite think that was going to match up with this side over here. Okay, so ambiguous cases can result in no solution.